When astronomers confirmed the existence of Proxima b, orbiting the faint red star Proxima Centauri only 4.2 light-years away, the scientific world immediately took notice. This small, rocky planet circles the nearest star to our Sun, and it lies within the habitable zone, the region where temperatures could, in theory, allow liquid water to exist. That single detail transformed Proxima b from a point of data into a beacon of possibility. Could life exist so close to us, on the doorstep of our own stellar neighborhood? Proxima Centauri, however, is no gentle star. It's a volatile red dwarf, prone to violent eruptions and bursts of radiation strong enough to strip a planet's atmosphere bare. If Proxima b lacks a magnetic field, these flares could destroy any chance of habitability. But some models paint a more complex picture. If the planet is tidally locked, its same face forever staring at the star, then one side would burn while the other freezes in darkness. Between them, there might exist a narrow twilight belt, known as the Terminator Zone, where temperatures hover in a fragile balance. In that strip of endless dusk, conditions might allow water to remain liquid and stable, and perhaps, life to survive. It's a haunting thought, an entire world illuminated by perpetual sunset, where alien winds carry both warmth and cold, and where the faint glow of a red star never rises nor sets. If Proxima b does have an atmosphere, it could redistribute heat, creating pockets of temperate climate along that twilight rim. There, under dim crimson skies, could lie the best refuge for life beyond Earth. To probe these possibilities, scientists have turned to the James Webb Space Telescope. From its quiet orbit far from Earth's interference, Webb examines faint light from distant stars and their planets. By splitting this starlight into its colors, astronomers can detect the chemical fingerprints of gases such as oxygen, methane, or carbon dioxide, all potential biosignatures. But there's a problem. Proxima b doesn't transit its star from our viewpoint, so Webb can't observe starlight filtering through its atmosphere directly. Instead, researchers use indirect clues, subtle shifts in the star's motion, tiny changes in reflected light, to infer what the planet might be like. Future observatories, such as the extremely large telescope in Chile, are being built to sharpen those clues into a clear picture: composition, temperature, maybe even hints of weather systems. While telescopes search for chemical life, radio astronomers are listening for technological ones. Projects like Breakthrough Listen have pointed giant antennas at the Proxima Centauri system, scanning for structured radio signals that might reveal the presence of an intelligent civilization. So far, the silence remains, but that silence only deepens the mystery. What kind of life could exist there, if any? Under the reddish glow of a cool star, photosynthesis as we know it might not work. Organisms could evolve to use infrared light, developing pigments or metabolisms entirely alien to us. Perhaps they dwell beneath the surface, or within underground oceans protected from radiation, drawing energy from the planet's core. On Earth, life has shown remarkable adaptability. Extremophiles, organisms that thrive in acidic lakes, deep ocean vents, and frozen wastelands, prove that biology can persist without sunlight, without oxygen, even amid toxic chemicals. If such resilience exists here, why not on a neighboring world bathed in perpetual twilight? Proxima b could harbor microbial life that relies on chemistry rather than sunlight, unseen, yet alive. Its discovery has also reignited one of humanity's oldest dreams: interstellar travel. Since it's our nearest potentially habitable world, Proxima b represents the first tangible destination beyond the solar system. Concepts like Breakthrough Starshot propose using powerful ground-based lasers to propel microscopic spacecraft, light sail probes, toward Proxima Centauri. Traveling at a fraction of light speed, they could reach the system within a human lifetime and send back images of an alien world bathed in red light. But enthusiasm is always tempered by caution. Proxima b may sit within what astronomers call the habitable zone, the sweet spot where temperatures could allow liquid water. Yet that does not guarantee habitability. The planet orbits extremely close to its parent star, Proxima Centauri, a restless red dwarf that frequently erupts with powerful flares and torrents of radiation. These outbursts can strip away the fragile layers of a planet's atmosphere, atom by atom, leaving the surface barren and exposed. Over billions of years, such cosmic weather could have transformed Proxima b from a world of oceans into a world of dust and silence. Still, hope endures. Its Earth-like mass, about 1.3 times that of our home planet, suggests a solid, rocky surface. Beneath that surface, there may exist a molten metallic core, churning and spinning, perhaps generating a magnetic field strong enough to deflect at least some of the star's fury. If such a shield exists, it could preserve parts of the atmosphere, maybe even small reservoirs of liquid water, the cradle of all known life. And even if life never bloomed there, Proxima b remains a symbol of cosmic potential. It stands as proof that the universe repeats itself, that Earth is not a single miracle but one of many possible outcomes written into the laws of nature. Across light years, planets like this whisper the same story, that the ingredients for life are everywhere, waiting only for time and stability to awaken them. The Alpha Centauri system itself might harbor other hidden worlds, quieter, gentler, more forgiving. Worlds that could orbit in silence, untouched by radiation storms. Each new telescope, from the James Webb Space Telescope to the next generation of ground-based giants, sharpens our vision and lengthens our reach. With every improvement in our technology, the shadows grow thinner, and new candidates for life emerge from the darkness. And every discovery brings us closer to the oldest question humanity has ever asked: are we alone? Whether Proxima b turns out to be a desolate wasteland or a living world bathed in faint crimson light, it has already changed us. It has reminded us that the night sky is not just a ceiling of stars, but a landscape filled with destinations. Our search among the stars is not merely scientific, it's deeply human. We explore because wonder is part of who we are. Curiosity is our inheritance, our engine, our compass. We look to the heavens not only to find life elsewhere but to understand life here, to see how rare, fragile, and precious existence truly is. Each telescope, each radio signal, each faint glimmer of light carries a story from the deep past, a story waiting to be translated. Every signal we chase through the void might be the beginning of a conversation billions of years in the making. Proxima b may never feel the tread of human boots, yet it already fuels our imagination. It invites artists, scientists, and dreamers alike to picture what could be: alien oceans beneath dark red skies, plants that feed on infrared light, creatures that thrive in eternal twilight. It is both a mystery and a mirror. It reflects our fears, our hopes, and our boundless desire to reach beyond the sun. It reminds us that discovery is not about finding new worlds alone. It is about expanding the limits of what we believe possible. Somewhere out there, among the countless stars, another world may be waiting for its dawn. And when we finally see it, when our instruments catch that faint blue-green shimmer or detect that perfect chemical signature, humanity will know that it was worth it. Because in the end, the search for life among the stars is the search for ourselves. A reminder that even in the vast silence of the cosmos, the human spirit refuses to be quiet. We keep listening. We keep looking. We keep dreaming, because that is what it means to be alive beneath the stars.